Hello everyone, I hope you guys are doing well. So today we are back with one more interesting interview problem which we are going to discuss in today's session. So without any further delay, let's get started. I am your friend, your host enqueue. So stay tuned with me. So the problem is implement a queue by using a stack. So let's go through the problem, what the problem is all about. It says in JavaScript we could use array to work both as a queue and as a stack. How? Let's understand it. So it's a simple array which says 1, 2, 3, 4 and we can push an element to the array which inserts a new element at the back of the array, and we can do the pop as well which removes the element from the back of the array. So it says it's a stack implementation where we are pushing the element from the back and we are removing the element from the back, which is last in first out, right? And the second example is same array and we are inserting a new element at the back. Element 5 is inserted and we can use the shift method which removes the element from the start of the array, which is FIFO, first in first out. Now suppose it says we have been given a stack class, implemented stack class, right? It says, can you implement a queue by using only above stack? A queue must have the following interface. It should have an element to insert. It should have a method to insert an element, peek to get the head element like the start of the queue, dequeue remove the head element like to remove the very first element, like similar to array.pop which does that from the last, and a size element which returns the total number of elements. And it says you can only use stack as provided. So we can only use stack as a data structure, underlying data structure. We no longer have access to the arrays. Cool. I hope we got the problem statement. We have to implement a queue by using only the stack data structure. That means we have only LIFO, last in first out, as a data structure available, and here we have to implement the solution. Okay, so now let's understand our approach to solve this problem. So for that I will switch my screen. I hope you guys can see my screen. And here, first of all, let's understand what a queue is. Okay, so this is queue where elements get inserted from the last and it gets removed from the first position, like from the head of the array. So this is first in first out implementation, and the given data structure to us is LIFO, which is last in first out, right? So if I implement the same here, 3 and 4, so the very first element which I can remove is the 4 only. But what we want is, by using stack data structure, I want that the very first element which is inserted, that should be removed. Okay, so it's a bit challenging, right? So we cannot use array or we cannot use any other intermediate data structure. So one possible solution can be, if we could have been allowed to use any other data structure, right? So this is the very first element, right? I could have saved these many elements as an intermediary layer, right? I could have saved these elements as an intermediary data structure, maybe in an object or an arrays, and then I could have removed this one, and then I have pushed these elements back into the stack. But that is something which we are not allowed to do. So the possible solution is, we can maintain 2 stacks here, right? And this stack will serve the pop purpose, basically when we want to remove the elements from the queue, right? And it would be exactly the reverse order of this stack, right? It will be linked to this stack. So we will call it in stack when we want to like add new element to the queue, and this will be called the out stack when we want to read the head of the queue, or we want to remove the element from the head position. And how it will work is, so when we want to insert the element, for example, consider this scenario only. Say we inserted 1, 2, 3 and 4 in the queue, so it gets added in this stack, right? Whenever we want to read the head of the queue, or whenever we want to remove the head of the queue, what we will do is, we will first analyze this particular out stack. If there is an element in this stack, use that as the queue, else start transferring elements from the in stack to the out stack, right? So the very first element is 4, so 4 comes here, then 3, then 2, then 1, right? So the elements will be reversed until this gets empty. So this is not here now, this is not here, this is not here, this is not here now, because the elements, all the elements we have transferred to the out stack queue, right? Now the order is reversed. The element which was inserted at the very first position becomes the top of this particular stack, and now we can start removing the elements from here. So this 1 goes out, then 2 goes out, and after 2, say we do the insert operation for few more elements, for example 5, 6 and 7. So those inserts are happening in the in stack, and after 7 there is a one more out operation, right? So as per our logic, we will say if the element does exist in the out stack, that should be given priority. So 1 or 2 are already deleted, so next element is a 3, and after that is the 4. So all those elements have been removed, so this stack is empty now. Okay, so there is no element now here. And now once this operation happens, once more like delete operation happens, we will see that out stack is completely empty now. What we will do is, we will start transferring the element from here to here. Now 7 comes here, 6 comes here and 5 comes here. Now 5 again becomes the top of the out queue, which is the oldest element in the next insert operations, and this goes out, and this 6 remains here, and this becomes again empty. So that way, by using two stacks, one primarily for the insert operations, which is called in stack, and second for the read and the delete operation, which is called the out stack, we can implement a queue data structure. So let's try implement here in the code as well. So we are back to our code here. So what I will do is, I will write a constructor here first, and I will initialize two class members. One is this dot in stack is equal to new stack, because stack is given to us here, it's given us here as a available data structure, and this is out stack. Right, so whenever we want to add a new element, we are, as per our discussion in the problem statement, it will always go in the in stack only, in stack dot push. The method available is us is push, because that is a method available in the stack data structure. So we will say push and element. Right, now whenever we want to read the element, so read is the head of the queue, head is the start of the queue, and in our discussed solution, it is the top of the out stack. So what we will do is, if this dot out stack dot size, like if out stack has elements available, right, then we will say this dot return this dot out stack dot get the top element, its peak. So it will give the top element, right? But if it's empty, right, that means if this dot in stack dot size. If there are elements in the in stock, then what we will do is while this dot in stack dot size, until there are elements in the in stack, we will start pushing it to the out stack. So here we will do is this dot out stock dot push what this dot in stack dot peak. That means pick the element from the top of the in stack, right? Not pick, actually it would be pop, because we want to remove the element, we just don't want to get the element. So remove the element from the top of the in stack and insert it into the out stack until the in stack is empty. So until here we have populated our out stack, and now we can simply return the return safely the topmost element of the out stack. And if there is nothing, I think we can return nothing, so we can simply do return. And the size of the queue is basically is simple, it's return this dot in stack dot size plus it's a sum of the in stack plus out stack dot size. Size is also done. And the dequeue is also similar to peak, only it's just that instead of peak we will do the pop here, and the logic will remain the same. If the out stack has elements, pop the topmost element, and if in stack has elements, then until the in stack gets empty, start populating the out stack by popping the in stack, and then at the last do the pop from the out stack. So I will copy paste the same function here, and it's just that I will pop the last element here. So let's review our implementation once. So we initialize two stacks, in stack and out stack, and in stack is used to push the element, so that is fine. Peak of the queue is used to read the element or read the head of the queue, and this is using this our stack implementation only. Out stack, if there are elements in the out stack, use that, else use the in stack. Size is the sum of the in stack plus out stack, and at the last dequeue. And if we submit it, cool, our solution worked. The underlying test cases which were there for this particular problem, all the test cases are passed, and we can have a look on that as well. Peak is working, queues size is working, queues dequeue is working, queues insert is also working, and Q1 2, it inserted 2 elements and then it dequeued 1. So all the test cases are working. So this is how we can implement the queue data structure using only stack, by using two stacks, one primarily for ins and one primarily for outs. I hope today's session was insightful. You get to learn some new things, and if that is the case, I would say please consider subscribing to our channel, like and share to our channels. That gives us the motivation to create such more insightful videos for you guys. So see you soon in the next video. Until then, take care of yourself. Bye bye. Take care.